So remember, when we're solving a basic system, we're trying to figure out where they intersect. So in the previous slide where you saw the two graphs, you looked for the points of intersection. So when we have two linear equations where they make lines, we're just looking for that one point of intersection. But later, when we start with conics, we're going to look for more than one solution, but it's going to be the same process. Okay, so when we look at an equation, we first want to go, okay, would substitution or elimination be easier? So substitution, remember, is best when you have a variable that's easy to solve for. So if I had either one that was already y equals or x equals, or it was easy to get into that form, then substitution would be your best way. If both of the equations are in standard form, meaning the x and the y are on the same side and just the constants on the other side, then generally speaking, elimination is best. So remember, elimination is where we multiply one or both of the equations by a specific number. Okay, so remember, we're wanting to eliminate either the x's or eliminate the y's. So we need either the x's or the y's to be the same number but with different signs. So we want them to be opposite. So if we look at our problem here, we have x minus 2y equals 4 and 3x plus 4y equals 2. So we could either multiply this first equation by -3 so that the x's are opposites, or we could multiply the first one by +2 to make the y's opposites. It does not matter, just pick one and go with it. So I'm going to multiply by -3. So that means you're going to multiply every single thing, even the other side of the equation, so that, remember, we're not trying to change the equation in value, we're just trying to change the look. So we're going to multiply -3 throughout. So we have -3x plus 6y equals -12. And then remember, it's a big addition problem. So 3 plus -3, the x's are eliminated. 4 plus 6 is 10y. 2 plus -12 is -10. So now we're just going to solve that basic equation. So y equals -1. So remember, we're looking for an ordered pair because we're trying to figure out where these two lines intersect. So we know the y coordinate is -1, but now we're going to plug that -1 in for y into one of the two original equations. Again, it does not matter. Just to show you, I'm going to use the second one, but you could just as easily have put this in for y in the first one. So there's our first our equation with the -1 substituted in, so that gives us 3x minus 4 equals 2. And now we're just going to solve that basic equation. So we're going to add 4 to both sides, divide by 3, and so 6 divided by 3 is 2. So our ordered pair is 2, -1. So these two lines, if we were to graph them, would cross at 2, -1. Okay, so remember, the whole purpose of this is this point would make this equation true if we were to plug it in, and this equation true if we were to plug it in.